We have talked about the molar mass of elements and how we can find it using the periodic table. Well, we can also have the molar mass of compounds. And so remember that the relative masses of molecules we can calculate from the atomic masses. So if we're talking about one formula mass, or the mass of one molecule of water, we would take 2 times the atomic mass for hydrogen plus the atomic mass for oxygen and add these together to come up with the mass of water. For 1 mole of water, it contains 2 moles of hydrogen and 1 mole of oxygen. And I know this can sound a little confusing. How can 1 mole of water have 3 moles of the elements? But you can think about it like a sandwich, right? So each one sandwich has 2 pieces of bread and some meat in it. Same idea with our moles of water. We've got 2 hydrogens and an oxygen. Got 2 moles of hydrogen, 1 mole of oxygen. To find our molar mass, we're going to take the mass in grams of hydrogen times 2 plus the mass in grams of oxygen to give us our molar mass of water. And this would be 18.02 grams of water per mole. So this allows us to find the number of carbon dioxide molecules in 10.8 grams of dry ice. So we can start by finding the mass of our CO2. So we're going to take the mass of our carbon off of the periodic table plus 2 times the mass of oxygen will give us the mass of our dry ice, or carbon dioxide. Okay. Now we can use dimensional analysis. We've got a conversion from grams to moles. We can use our dimensional analysis to solve our problem. We're going to start with our 10.8 grams of CO2. We want to cancel the grams, so we're going to use our molar mass. To get from grams to moles. Now if we want to find the number of molecules, we're going to use Avogadro's number. Our moles will cancel. We'll be left with molecules. .48 times 10 to the 23rd molecules of CO2. Here's a practice for you. What is the mass of 4.78 times 10 to the 24th NO2 molecules? Because we're trying to find mass, we're going to need the molar mass of NO2. So if we go to the periodic table, we can find the molar mass of nitrogen plus 2 times the molar mass of oxygen And typically 2 decimal places is far enough to go on our masses for significant figures. So 46.01 grams per mole for our NO2 molecules. I'm going to start with the number of molecules. We want to get to the mass. So from molecules, we're going to have to go to moles. We're going to use Avogadro's number. Remember, if you're using a calculator, you may need to put that in parentheses so you get the correct answer. And now we can go from, this is molecules. Now we can go from moles to grams using our molar mass. So 1 mole on the bottom, 46.01 grams on top, so our units cancel. We end up with 365 grams of NO2. We would expect it to be larger because our value that we started with is larger than a mole, so we would expect it to be larger than our molar mass. Now, when we use molecular formulas or chemical formulas, they have conversion factors built right into the formula. So it's a relationship between the number of atoms and the number of molecules, or moles of atoms and molecules. And we can use these to help us figure out the amount of one particular element in our compound. So here's an example. Find the mass of hydrogen in 1 gram of water. So if we wanted to do this, we could start with our 1 gram of water. We're going to have to convert into moles so that we can compare our hydrogen to our water. We're going to need our molar mass. So 2 times the mass of oxygen plus 2 times the mass of hydrogen plus the mass of oxygen gives us the mass of water. Okay, now because we have a conversion from grams to moles, we can put the grams on the bottom, 1 mole on top. Just going to label this a little bit better. So now we're in moles of water. We want to go to moles of hydrogen. So for every 1 mole of water, how many moles of hydrogen do we have? 2. And then we can go back to mass. 1 mole of hydrogen is 1.008 grams of hydrogen. And we can find, if we multiply across the top, divide by anything on the bottom, we have 1.1119 grams of hydrogen. And we would have 3 significant figures, so we would report this 1.112 grams of hydrogen. So because we knew what the formula of water was, H2O, we could convert between water and hydrogen. This is going to be a common way that we do our calculations, starting with grams, using molar mass to convert to moles, doing a conversion from moles to moles and then back to grams using molar mass. We will see this again and again. Here's a practice for you. How many grams of sodium are in 6.2 grams of sodium chloride? Pause the video and calculate. We will need the molar mass of sodium chloride. So we'll have to add the mass of sodium plus the mass of chlorine, one of each. That is what our formula tells us. We're going to start with our 6.2 grams of NaCl. Using our molar mass, we can convert to moles. The grams need to go on the bottom, 1 mole on top. Now we're trying to find grams of sodium, so we want to go from moles of sodium chloride to moles of sodium. Because there is just 1 sodium in our formula, 1 mole of sodium chloride is equal to 1 mole of sodium. And now we're going to go back to mass. So 1 mole of sodium is 22.99 grams. So for our mass of sodium, 2.4 grams of sodium. This is about what we would expect because the mass of sodium is about 1/3 of the mass of our overall compound. So the mass of sodium would be about 1/3 of what we started with.